Hi everybody, Jacob Price here with XLR8 Equine. I wanted to touch base and answer a couple of questions that we get all the time. The most recurring question that we get is, what is the difference between one wavelength and the other? When do I use 660, 850? What about other wavelengths? Red, near infrared, what's the difference? So I wanted to touch base and we can go over and see what the science and research says. The first thing we have to understand is what the electromagnetic spectrum is. Everything from radio waves to gamma rays is encompassed in that electromagnetic spectrum. There are things in the body, structures in the body, parts of the cell that are photoreactive to certain wavelengths of light. NASA's been studying this since the late 70s, early 80s. We've been using this in laser therapy for quite a long time. Problem with the laser is it doesn't take much to do too much with a laser. The other thing is they're expensive. Technology has caught up with us so that we have the ability to pinpoint the exact wavelengths of light that we're looking for because of LED technology. It's just getting better and better. As we do that, we can pinpoint the wavelengths that we're looking for. And I'll tell you the ones that are most commonly used and the ones that we use. 660 nanometers is still visible. It is red. It's what we typically think of when we think of red light therapy. The problem with 660 nanometers is that it does not penetrate very deeply. 660 nanometers is within that window where it is photoreactive in the mitochondria, which means as we expose that mitochondria to different wavelengths of light, in a certain window, it creates more of an enzyme called cytochrome C oxidase. Now, cytochrome C oxidase is very important. If you look it up, it'll say it's the terminal link in aerobic cell respiration. What that means is an enzyme is something that is a catalyst for a reaction. In this case, the reaction is actually moving ions across the membrane of that mitochondria. What does that do? Well, in that instance, what we're doing is changing that electrochemical gradient so that the end result is it fires off another ATP. We can continue to increase the availability of this cytochrome C oxidase. And the end result is we have more ATP. Back to 7th grade science, ATP is pure energy for the cell. ATP is, I think of it as a currency as it moves through the body. Most every process in the body requires an ATP in exchange for whatever process it's trying to execute. So when we can increase ATP production, then that closes that loop in cell respiration. That means that cells replicate faster. That means that the inflammatory response is not suppressed, but sped up. And that's quite important because the inflammatory response is how the body actually heals itself. So we have to think of red light therapy more in the vein of the way that we think of nutrition. Proper nutrition lets the body do its own work rather than we think of drugs. Drugs suppress the inflammatory response. That's not our end goal here. What we're trying to do is help the body push itself through to the healing on the other side. An inflammatory response is a very important part of the body's natural healing process. That window is from about 600 to about 900. Once we hit that 900 mark, reactivity starts to fall off pretty sharply. That means that the wavelengths that are above that 900 mark are not going to have the same metabolic process that anything below that 900 mark does. 660 is still in that window, and it does a great job with wound care. And that's the most, quick and dirty way that we can remember it is red light does great for wound care and for skin issues. As we move up, we get to another wavelength that has been pretty commonly studied. They haven't used much in the 700s. They haven't found many benefits that are, it doesn't penetrate a whole lot deeper than 660 does, and it doesn't do much of a better job than like your 850 does with metabolic response. And so it's just not used very much. You won't see anybody, trying to use that. Once we get up to probably one of the most studied and researched wavelengths is 810. 810 has been researched and studied and used a lot, mostly because that's what the lasers were when they started this before, as they were trying to figure all of this out. That's the wavelength of light that came to it. There's a lot of research on that, and again, as we move up until we get to that 900 point, then we're getting deeper and deeper penetration. We talked about red light. Red light does not penetrate that deeply, but as we move up, 700 nanometers is going to penetrate a little deeper than 660, and then we're going to add some penetration, some depth of penetration, even more at 810. And then as we move up in the penetration, we're going to 850. 850 is one that we need to spend some time on. It is called the gold standard of infrared therapy. And the reason that it is used very commonly and with great success, it is as high, almost as high as we can get in penetration before it starts falling off, and I'll tell you why it falls off in a minute, while still maintaining that reactivity in the mitochondria. We're getting good mitochondrial results. We're getting the good energy, great soft tissue regeneration ability. With that 850 nanometers, it's penetrating about as deep as we're going to find when we compare apples to apples. What we have done is pushed as high on that penetration scale as we can while maintaining reactivity in that mitochondria via the cytochrome C oxidase. Once we get up past there, once you hit that 900 nanometers mark, 900 is kind of a right about, right? Because, the cell doesn't know what our measurement is, but it happens to break right about 900 nanometers. Once you get to that mark, that near infrared energy starts to become very reactive with water. Very important that we understand what structures we're using this for, right? If we're talking about soft tissue, there's a great deal of water there, but there's also a great deal of water in the skin, right? The skin has a lipid bilayer, and all the soft tissues and all those cells are filled with some type of fluid, and which is mostly water, and the interstitial fluid is mostly water. It becomes very important that we understand what tissues we're using this with. Also, once we step above 900, there's kind of a byproduct. As that water absorbs that energy, there's a byproduct that is actually heat. Once we hit 900 nanometers, the penetration starts to go down, because as the water starts to absorb that energy, it absorbs it, it scatters it, so it's just not going to reach quite as deeply. And that's just a scientific fact. 940-ish has been shown to travel farther in other medium, like air. There's not as much scatter in the air. If we're trying to reach through the skull, which we're definitely not trying to reach through the skull. If we were trying to reach through skull, through bone, yeah, we can justify moving up into the 940s and the 1060s and the whatever. They don't do a good job in soft tissue. And 99% of what we're looking at here in the horse is soft tissue. Looking at tendon and suspensory rehabs, and we're looking at, muscle regeneration, and we're looking at recovery after work and that sort of thing. And we need it to penetrate as deeply as we can. And 850 seems to be, in soft tissue, seems to be the best one for those applications. Don't get caught up in a lot of people take a look at it and they say, well, a higher number must be better, right? But that's a very simplistic way of looking at it. We have to know what media we're trying to treat, how those different wavelengths react with those different substances. So the water is important, but also the reactivity with cytochrome C oxidase, the ability to create that ATP in the mitochondria, is crucial for the healing and for the stuff that we're getting. So that's why we're using 850. That's why it's the gold standard. Thanks for coming by and letting me have a talk with you. I appreciate it. And if you have any questions, please, we're happy to answer them. Drop a comment, play nice in the comments, and we'll catch you on the next one.